Hey guys. The next trend I want to talk about is atomic and ionic sizes, and I'm going to relate this back to our effective nuclear charge. So we want to look at our trends in atomic size and explain why the trend exists, and then describe the changes that occur when an atom becomes an ion and how the relative sizes can be summarized, and then explain the trend within an isoelectronic series. When we're talking about atomic sizes, we talk about different types of radii, so different methods to determine our atomic radius. So there are different methods used to determine the atomic radii. And they're going to work good in some cases and not good in others, which is why there's different ways of determining this. The first one is called the non-bonding atomic radius. It's also called our van der Waals radius. And it's half of the shortest distance between two nuclei during a collision. Okay. And then our next one is called the bonding atomic radius. Or our covalent radius. And this is half the internuclear distance. When atoms are bonded. And this is the method that's most commonly used in what we will be using, and it's what's pictured over here on the left. So there are reasons why it adopts this radius or this distance, and it's based on the atoms not being able to get any closer together because of electron-electron repulsions, and then it doesn't want to be any further apart because of attraction between the electrons of one atom and the protons of the other atom. So within our atomic size, we have a periodic trend, right? And the trend itself is going to be, as we go across the periodic table, we're going to decrease in size. As we go down the periodic table, we're going to increase in size. So atomic size, or atomic radii, decreases going across a period. And then it is also going to increase going down a group. So as we go across a period, the thing that's really going to cause that decrease is that increase in our effective nuclear charge. So going across the periodic table, the effective increases. The increased pull of the nucleus is going to pull electrons in tighter. And as it pulls electrons in tighter, it's going to decrease the size of the atom. Hence, the size of the atom gets smaller. As we go down the periodic table, we are just increasing our number of electrons significantly, which increases our electron-electron repulsion, which increases our size. So going down a group, number of electrons increases significantly, which leads to more electron-electron repulsions and greater size. When we compare our parent atom with the ion, it depends on what type of ion we produce. So ions are going to have a different size from the parent, which is the neutral species. And we can also talk about effective nuclear charge here, right? So if we take and we increase our effective nuclear charge, we're going to decrease our size. If we decrease our effective nuclear charge, we're going to increase our size. So size of the ion depends on our Z effective. Greater Z effective, smaller size. Smaller Z effective, greater size. And we're comparing directly to our parent atom, so it should be pretty easy. So if we take and we remove an electron, we have fewer electron-electron repulsions and fewer electrons in between our outer electrons versus our nucleus itself. So that's going to pull electron density in because of our greater effective nuclear charge. So cations, the ones that I've just described, cations will always be smaller than the parent. So electrons are removed. This leads to fewer electrons in the electron cloud. Which leads to fewer electron-electron repulsions and a greater effective nuclear charge, both of which result in a smaller size. Our anions, always larger than the parent, because now we're shoving more electrons in, right? More electrons, more electron repulsions, and smaller effective nuclear charge, because now we have more electrons in between our outer electrons and our nucleus, which leads to a smaller or greater screening, smaller effective nuclear charge. And we can see this directly by looking at an isoelectronic series. Within an isoelectronic series, we have a series of ions that all have the same number of electrons. So what happens in an isoelectronic series, the ion size will decrease with increasing nuclear charge and effective nuclear charge. So let's look at this 10 electron isoelectronic series. We're going from O2 minus to Al3 plus. Each one of them has 10 electrons, but as we go from O2 minus to F minus to Na plus to Mg2 plus to Al3 plus, we increase our number of protons. So we are literally increasing our nuclear charge, but we're not changing our number of electrons. So as we increase our nuclear charge, we are significantly increasing our effective nuclear charge. So we are decreasing our ionic radius within here. Okay, that is everything for atomic and ionic sizes. I will talk to you guys in the next one. Bye.